All right, in this lesson we're going to look at the law of sines, and this is really our first attempt here at learning anything that's not right triangle trig. So everything we've done so far has been for right triangles, SOHCAHTOA, and we did Pythagorean theorem. And so for now we're going to look at law of sines, which is for not right triangles. And the law of sines is basically the sine of any angle over its opposite side, and that is proportional or equal to the sine of any other angle over its opposite side. So if you see here, we have the sine of A color-coded in red. So the sine of that angle A divided by its opposite side A is equal to any other side, so the sine of angle B over its opposite side, or the sine of angle C over its opposite side. And really you're only going to use two of these three. So you're not going to set up a whole equation with three proportions in it and two equal signs. You're going to use two of the three. So let's take a look how we'd use it. Let's say here we are trying to solve for this missing side x, and we cannot use SOHCAHTOA because it's not a right triangle. So we have to do something different, and we're going to use law of sines here to solve for x. So let's take, I'm given this angle 58 here. So let's take the sine of 58 divided by 16. And let's set that equal to, what else do I have? The sine of 61 divided by x, and so I'm missing that side. So I say the sine of 61 degrees divided by my unknown x. So here I have a proportion, and to solve a proportion you can use the cross products property or cross multiplying, and we'll cross multiply and we'll set the cross products equal. So the red cross products would be x times the sine of 58, and that would equal 16 times the sine of 61. Now I'm trying to solve for x, so there's my variable, and my variable right now is being multiplied by the sine of 58 degrees, which, remember, that's just a number. So to get rid of that, I'm going to divide both sides by that number. So take both sides, divide them by the sine of 58. And so on the left side, the sine of 58 over itself is 1, so that's going to eliminate. And x will equal this big expression right over here. All of this stuff. Sine of 16 sine of 61 over 58, sine of 58 degrees. So I go over to my calculator and I evaluate that. 16 sine 61. So I say 16 sine 61. All that divided by, I'll have to go back because I forgot. Whoops. Sine of 58. Enter. 16 sine of 61 divided by sine of 58, 16 and a half units. So we go back, we just make sure that makes sense. All of that above, whoops, I'm highlighting it. All of that above was 16.5 units. Does that make sense for x? Is that going to be 16 and a half? Well, in geometry you learn that the bigger the angle gets, the bigger the opposite side gets. And so if 58, opposite side of 58 is 16, then since this angle 61 is bigger, we'd expect that opposite side to be bigger, not much, which it is not much bigger at 16 and a half. So there we're missing a side. That's finding a missing side. Let's take a look at finding a missing angle. Same process. take a look at what we have here. We have a angle measure of 70 and an opposite side of 26, and an angle measure missing x and an opposite side of 24. And maybe I should have color coded those a little better, so we'll go greens for the x over 24. So you got to make sure you do the opposite side over that angle. That's opposite of it. So let's set this up. We have the sine of x over its opposite side, which is 24, equal to the sine of 70 over its opposite side, which is 26. There's another proportion. Set up your cross products and solve for x. So after I cross multiply here, I will have 26 times the sine of x degrees equals 24 times the sine of 70 degrees. And my variable is an angle. So to find that angle there eventually, I'm going to end up using the inverse sign. So I'm going to divide both sides by 26. Get rid of that. That's going to cancel out. I'm left with the sine of some angle is equal to this expression right there. The sine of some angle equals that expression. So what is that expression? Remember how that works. We're going to just look up that value in the table of values or using our calculator. And what we do then is, let's just try a little different way to give a little different look at this. Let's say 24 sine 70 over 26. So 24 sine 70, all that divided by 26. What is that value? Make sure I did it right. 24 sine 70 divided by 26, correct? And that value, according to our calculator, is 0.8674. So this stuff in red here is 0.8674. All right, so the sine, what angle is the sine equal to that ratio? Well, let's take a look at a table of sine values. So here is a table of sine values, and it's pretty small, so I apologize for that. But if we look up that value that we just wanted to find there, so if we look back to what value was 0.8674. All right, well, if I look in this table, 0.8674, that's going to be 0.8660 is right there. So 0.867 is somewhere between those two values, which is 60 and 61 degrees. Which makes sense according to our picture. And your calculator, of course, has this information stored. So what we do with our calculator, I just wanted to help you understand where these values are coming from, but we take the inverse sine of, and then if I just take this stuff right here and copy that. So if I get Control C is copy, and if I paste it right in there, Control V, universal paste, enter, that's going to give me a precise value of 60 and 1600 degrees. Okay, so 60 and 1600 degrees. Let me get back to where I was here. So 60 and 1600 degrees, does that seem about right for our answer here? 60.16 degrees. If you look at the sides, opposite of the bigger angle is the bigger side, so it does seem to make sense. And that's how you find a missing angle using law of sines. Let's take a peek at a couple more problems here. This is a case, if you remember in geometry, where you may use law of sines. And in geometry, you did some congruence postulates. And for the congruence postulates, there was never any congruence postulate that was side-side angle, because having a side-side angle in common did not guarantee that there was one unique triangle. So you'll see when we do law of sines in this problem that it's going to give us a weird answer, and that's because it's side-side angle. And looking at the picture here, I can take a look and see here I have an angle and a side, or a side and an angle, and so that's going to actually create two possible triangles that I'll show you after I'm done with this. So let's go ahead and just set up law of sines and see what we get for x in this case. So let's go for the sine of x, and I didn't really intend that to be red. Change that to black here. So the sine of x degrees over 19 is equal to the sine of 18 over 10. And we'll just do the same thing that we just did. We'll find the angle. So we cross multiply. We have 10 sine of x. 10 times the sine of x is equal to 19 times the sine of 18. And we'll divide both sides by 10. And what we have there then, I'll come over here, is the sine or inverse sine of, and then that'll be all this stuff here. So the inverse sine of 19 sine of 18 all over 10 will give us that angle. So let's calculate that in the calculator and see what we get. The inverse sine of 19 sine 18 over 10. 19 sine of 18, all of that divided by 10. Okay. Now, I had to make an adjustment there. I need to do the inverse sine, of course, of 19 times the sine of 18 divided by 10 to get the angle, and so that gives me an angle measure of 35.95 degrees. So roughly 36 degree angle measure. So if I look at that on my picture, does this look like a 36 degree angle? It does not look close to a 36 degree angle. So what's going on here? Why is it giving us bad information? That this is not 36 degrees. So here's what's going on is if you have an angle side or side angle and you're setting up law of sines, you might have two possible answers, and your calculator will always give you the smaller acute answer. And so let me show you that there are two possible triangles here. So I'll extend this line of that side, and I will rotate this side 10 so that it also touches the long side of the triangle. So now I have a triangle here. I'm going to highlight it. That has the same angle, 18. Okay. It has the same 19 unit side that we had before, and it also has the same 10 unit side that we also had before. So when you have angle side like we do here we have angle side or side there. There's two possible angles. So what the calculator will give you first is the acute angle, which is this 36 degrees. That's this angle x. So angle x essentially there's two values. X is up here and x is over here. So in order to calculate the obtuse one, if you need the obtuse one, you need to take the supplement of 36, which is 180 degrees minus 36. Why do you have to take the supplement of 36? Well, let's look at it. What we really did was we created an isosceles triangle here and here, both with sides of length 10. So if those sides are the same, their base angles are the same, which means this is also 36 degrees here. And if that's 36, you know that this right here was 144 because they form a linear pair. So a lot of geometry coming into play here. So if you are finding an angle using law of sines and you have an angle side-side or side-side angle, you will have two possible values there. And if you need the obtuse value, you're going to need to find the supplement of the one that your calculator gives you. So watch out for that. I think I have one more here. Sometimes you'll be given a problem like this. And when you go to set it up, you go, okay, I got an angle here, so the sine is 62 over 24. And then I get to here and I'm thinking, well, wait a minute. I don't know what the opposite side of 58 is. I can't do this. I don't know the opposite side of 58. So we're sort of stuck here, but not really, because don't forget all the angles add up to 180 degrees. Actually, if I want to find the x there, I don't really care about this side at all. That side doesn't matter at all to me. What I really care about is finding this angle right here. And I can, of course, find that angle because all sides have to add up to 180 degrees. So if I have 62 and 58, those two together make a total of 120. And so how many more do I need to get to 180? I need 60. So now I can set it up. See, now I have my opposite side of 60. So you're given an angle to really find the other angle. So you got to use your brain a little bit and think about all your options. I'm not going to finish and solve this one because I think that you're probably catching on to that, and if not, you can look back. Otherwise, that's it. So that's law of sines, and I hope that helped. Thanks for watching.